lunch bell based on Azure Cognitive Services and Office 365. Thanks to all the sponsors of today's event. Without their support, such events won't be possible. Okay. It's only one more. That also working? Okay, so I will stand here and you have to focus over there. Let's quick fix this way. So thanks to sponsors. I don't know what is happening here, but it's okay. My name is Thomas Göllers. I'm working for a company called Solvion. Solvion is a consulting company based in Graz, Austria. We try to help our customers to achieve more with Microsoft Office 365, SharePoint, Skype for Business, Teams. I'm the team lead there for a team called Modern Workplace Solutions. Basically, I own everything: SharePoint, SharePoint Dev, SharePoint Infrastructure, SharePoint Consulting, Teams, and Artificial Intelligence. I will stand here and walk it out. Just focus over there.
Yeah, hi. My name is Stefan. I'm also working at Solvion. I'm doing the infrastructure and Office 365 technical lead part. My newest passion area is AI. I'm currently being awarded as an AI MVP. And I'm trying to push a lot of AI services into the modern workplace, into our solutions in order to make them smarter, make them more intelligent, and get the users working with them. So,
yeah, and one selfish thing first. 1st of December, SharePoint Saturday Vienna. You're all welcome, also in our city. Okay, today we have 4 cornerstones for main agenda points. Some background how we came up with the solution, a so-called business problem we're going to solve with technology. Then we try to have a big demo here. Actually, we prepared everything here, and Stefan is polishing, as always, in the last minutes, the training model here, and then we will see. What you're going to see is the 21st century dinner bell. The Teams team called it back in Redmond. Actually, it's a lunch bell because we do bell rings at lunchtime and not dinner, but yeah, different time zones, different cultures, Americans, maybe they will get it sometime. The background. This is a picture of our front door back home in the office in Graz. We only own a small part, so we're not that big company. Don't get confused with the picture. It's a marketing slide. And this is the view I used to have from my desk. So I looked straight out to our courtyard. To my right, so I was sitting here. This was my view over there. And every day at around 10:45, a truck arrives from a company called Rainer, and they provide nice things. So you know where to get lunch. Apparently, I had to move my offices, and this was my new view. So no more food truck. It's like 90 degrees the other side of the building. It's nice and green, and there's a kindergarten, and you see children playing. It's another thing that next to work is nice, but yeah, I don't see the food truck anymore. How can I solve this problem?
No.
Sorry, how can I solve this massive problem? First option would be create a recurrent event in Outlook. You can check my calendar afterwards. I have like 40 or 30 recurrent events in Outlook already. Not one more. Next option would be what we call ping a colleague. We use Skype for Business or Teams, so we start with ping each other. Are you there? And I can ask a colleague, do you see the food truck? As a team lead, it's not that comfortable to ask every day, can I go to lunch? Is it there? So this wasn't a real option. The third option would be stand up and have a look, but come on guys, be serious. It's not an option at all. The fourth option, use technology to solve the problem. And this is actually what we did. So how would a geek solve this problem? This is a sentence from the episode 2 of season 1 from Big Bang Theory, where Leonard the physicist explains to Penny the waitress how he sees her in terms of a physicist. Because she is a waitress, so she acts like a carbohydrate delivery system. And what we created is a mobile carbohydrate delivery system. That's the food truck monitor. That's why it's called Mocadesimo. The solution, or how is Mocadesimo? It's this fellow over here. The place where I used to sit, the new colleague sits there. We have red foam guy sitting there. There's a Raspberry Pi inside with a camera module connected to the internet, to Azure IoT. And what is happening is that around 10:45 a cron job starts taking pictures each minute, uploads the picture to Azure. An Azure function kicks in, takes the picture, moves the picture to Custom Vision API, and the Custom Vision API tries to detect the food truck. Above a certain threshold, it's currently about 78%, we say the car is here, and we inform our users by ringing the lunch bell in Teams, in Skype for Business, in Flow, whatever they want. So this is the solution we came up with. So Mocadesimo is sitting right here, watching out of the window to our front yard. And what's the architecture behind again? We have this little phone fellow sitting there. You can buy everything on Amazon. It's everything there. You will need, like, for the first, just the breakthrough, I played for 6 or 7 hours and I was done. So don't expect like 100 lines of code. It's very, very tiny and simple. It's more like connecting all the services that already exist. First, I was trying to do the math on my own. I have a computer vision background. I was like, yeah, this would be a fun project for the whole summer to code the algorithm to detect the truck. I was already like, okay, optical character recognition, detecting the slogan of the car, detecting the colors, and doing the math there. And then Cognitive Services API preview came out last year at Build. I tried it at home with some wine bottles. Amazing experience after only 30 pictures. So no deep mathematical stuff here, just using a predefined solution already done. In terms of the models, it's a Raspberry Pi 3 actually. This is the foam fellow here, the camera model, and some SD card, but you can also use a Raspberry Pi on a car that drives around. This is our mobile version of the system because the real one is really hard to carry, not the phone, but the food truck would be a problem. So we have also a food truck with us. And there's just also a Raspberry Pi. Basically, it's running Azure IoT services that are connected and that take the pictures. This is everything in terms of code running on the Raspberry Pi. Nothing more. 32 lines of code. Basically, it's with this line here, you take a picture, then you upload it to Azure, and you call Azure function. That's it. Azure command line interface helps you a lot. Azure CLI, it's just Azure login, service principal, user, okay. Azure storage upload, you take the image, upload it, and of course, I can basically get rid of this file here because I could connect the function already to Azure storage, so trigger it and just upload it. But for demo purposes and for easier debugging, printf, it's easier to do it step by step, but that's all you need on the Raspberry Pi. Everything else runs in Azure. I had a Linux background, but it took me some years now. But it was the hardest part of this thing was setting up the wireless mode on the Raspberry Pi, to be honest. This was way easier then. Okay, so everything we use is block storage, an Azure function, Custom Vision API, and then we store the results to a storage table. And the storage table simple has something like, okay, today's date, the car is not present, it's Saturday, so nobody's at work at home, but it would be like 16th of June, 11:04, I detected the car with a probability of, let's say, 92%. It's just an entry in a storage table, and this storage table can be called by Cortana, Amazon Alexa. An easy one, because you just put in a select query. It's an entry for today here. Is the probability high enough? And then say, hey, food truck is there. So microservice architecture that you can connect different services also to this simple one. The whole picture again in terms of the architecture. We have our food truck, the Raspberry Pi that takes the image, moves the image to Azure storage, then calls an Azure function. The Azure function reaches out to Custom Vision API, tries to detect the image. If the image is there with the food truck present, we send out a message to Teams, and we will show you later on. We already have something like a real bot that you can ask, is the food truck there? And it takes the images just for our mobile demo purposes. So we also have a Lewis model integrated, and you can say, take a picture, check for the food truck, and this is what I'm going to show later on. Okay, Stefan, your turn.
So, as I already said, I'm trying to push as much AI into services, necessary services like food management and stuff like that. So let's get into bots and cognitive services. First of all, I want to start with the evolution of computers in IT before we get into this bot and cognitive services kind of stuff. So back in the 80s, when I wasn't born, we had these things called desktop PCs. I don't know if you remember them. These were the predecessors of laptops and tablets and smartphones and whatever. And coming to the 90s, we had the internet wave where we could search, users could visit websites and do stuff on websites, which evolved a bit coming from the 90s, looking at it now. In the 2000s, we had this mobile wave where everyone was social and you could download apps from the App Store and have your Facebook, Twitter, and whatever with you all the time and just watching your smartphone instead of talking to your friends or family. But what does the future hold for all of this? Looking at the 80s, 90s, and 2000s. Well, from my perspective, it's like the future is conversational. So you're going back, sitting in front of your smartphone and just looking into your smartphone. Instead, you will have conversations with like digital agents, services, apps, and whatever. And therefore, you could use bots and agents in order to have like human conversations with services instead of clicking here, clicking there, searching this, searching that. You would have conversations via text, of course, but also via speech or via vision, for example. So this is basically the future where the AI stuff comes into play and where you have to think about, oh, how can I leverage my AI services into the services or apps I've deployed or running right now. So what are actually bots? This is a definition coming from the Cambridge Dictionary. So it's like a computer program designed to have a conversation with a human being, and of course especially over the internet. And this could happen via three different areas. First of all, written text. Second one could be vision, so images, videos, or whatever stuff. And the third, which is like the Champions League, is speech. So really talking to an agent, and the agent or bot understands what you're actually meaning and sets some actions based on that input you give the bot. So what is a bot, or what is a bot not? It's one thing, of course, it's an app. You can see it as an app or service which does automated task processing. And it solves the user's needs in the fastest way possible. So as you may know, some websites or apps, you have to click here, then do this, then do that, and then search for that in order to get the result you want to have. With a bot or with a digital agent, you can just ask the bot, hey, I want to have this or I want to see that, and the bot will give you the result instantly. So basically, should be providing the quickest and easiest way for users getting there where they want to get, instead of navigating through apps or websites. And what makes a bot actually great? It's not about how much AI the bot has. It's very important. It's not about how much language understanding it has or it offers. And it's not about whether it uses voice or not. You can also have great bots where you just upload images and they do automated tasks with them. So make sure you remember those kind of key points whenever you want to build up a digital assistant or a bot or a service that offers AI. So basically, your bots or bots in general, they consist of various areas. So you have your platform where the bot is hosted, for example, Microsoft Azure. You have intelligent tools like AI tools for cognitive services, language understanding, computer vision, speech understanding, and so forth. You feed the bot with in order to make it actually intelligent. And then you have your SDKs, like in the Microsoft world would be the Bot Builder SDK, in order to build and develop your bots using .NET, Node.js, Python, Java, or whatever. And on the front yard, you have your REST endpoint, basically spoken, where the services or users or other bots connect to and talk to your bot. So basically, it's nothing more than an app or service you can consume. And therefore, Microsoft has come up with the bot framework, which is actually their answer or platform for making and developing, building and deploying bots. And within the bot framework, you have your various areas. First of all, you have the channels you want to deploy your bot to. Could be the Microsoft ones like Teams, like Skype, like I don't know, Cortana. If you're using voice or text within Cortana, could also be like Slack, Facebook Messenger, Kik, or whatever other platform you want to deploy your bot to. So it's not limited to the Microsoft services, but it's quite open. And then you have your, let's say, digital services or intelligent services like the cognitive services by Microsoft in order to make your bot actually intelligent. So usually, if you build up a bot, it comes in stupid. You have to make the bot intelligent with cognitive services for language understanding, for text analytics, and for computer vision. And then you can choose, as I already said, for building up your bot, you go the .NET classic way or you go the Node.js way. And there, with the bot builder SDK v4, they're even releasing Python support, so you can build up your bot in Python if you want to, and Java. So it's quite open there. So how could you actually model a bot conversation? Because all of you know the simplest form could be Q&A. So you have your Q&A, question and answer database, or FAQ, where you basically have question, answer, question, answer, question, answer. And the bot then consumes the Q&A and checks, hey, the user has asked me this question. Do I have this question in my Q&A? If yes, what is the answer to that? Give it to the user. If not, just respond with, I don't know the answer, please ask me another question or anything else. Second one or second conversation model would be a bit advanced. Could be like using forms and flows in order to guide the user through the conversation, where you actually can capture data, build up like forms you would build in a web app or anything else. And this is a bit more time consuming in order to implement it. But of course, your users gonna love it a bit more than just having question and answer, as is more like a conversation you're building up here. And the third conversation model would be dialogue stance. So you basically think about what may my users ask the bot and come up with dialogues in order to react on the user intents and guide the user through the conversation with human-like dialogue then. And the last and Champions League conversation model would be bespoke, so you can basically roll your own state management and build it up on your own, which is the most time-consuming model you could implement. And for conversational mechanisms, you can use various like input types, going from text, media attachments, like as you can see here, cards and pictures and videos. You can use prompts in order to ask for something specific. You can use rich cards like the adaptive cards, which are basically deployed once or built up once, can be deployed to various channels, and they behave natively in those channels, and you don't have to think about, I'm doing a bot for Skype and for Facebook Messenger, I have to build it twice. No, you have to only build it once. It runs on both sides without the necessary adoptions. And of course, speech. So your bots could be speech enabled, but think about which language you're using, because right now I would only use English for all those conversations, because the other languages are rather, well, let's put it frank, not that good developed right now.
So, for example, a short question. I don't know about the Polish language at all, but do you guys have a lot of different dialects in your country? Because if you think of German language, if you talk to someone from Hamburg, or you talk to us guys from Austria, it's a totally different game. So the speech recognition needs to be aware of. I think my soon-to-be wife has a major in German literature. It's like 40 or 50 different dialects. So you move around 100 kilometers and the dialect is different. How should this thing came up with every different dialect? That's the hard thing we see day to day, because we also use this form of dialects in chatting. And the thing only knows this high German standard language and not our way of communication. So there is an option to train Azure already with your own wordings and your own verbs and samples. But in terms of dialects, this depends on the language. Sometimes it's not only one language, it's like 40 behind the thing.
And of course, Microsoft is pushing English because it's their language and it's the most spoken language.
They realize there are other people, but it takes some time.
Yeah, they're working on it.
Yeah.
And if you're done building your bot, you have to think about continuous improvement. So it's not, oh, I'm developing my bot, deploying to my channels, and that's it, never gonna touch it. No. You want, and especially for those intelligent services like speech understanding, like language understanding, you have to make it better and better and better in order to get the user using it not only once but day to day. And if you can imagine if the users put in a question and they don't get an answer for like 5 times, they're not going to use the bot anymore, because they will say this agent can't help me. So improve your bot or your services continuously using those Azure services you have in place in order to make it better and better and better. So I've already talked about those services for intelligence. If you look at this picture here, these are the cognitive services provided by Microsoft right now, which you can use for various use cases, not only bots, but especially for bots you could use the language category for, first of all, language understanding. So we'll see later on how that works. But you could also use like text analytics, so getting the sentiment of a given text. Is the user happy right now talking to the bot? Is he angry? Or what is the sentiment of the user talking to my agent, and therefore react on different kind of actions. But you could also use like all those Bing APIs for news search, for doing like video search API, so searching for videos in the Bing repository, and a lot of more stuff more. Or use like the Q&A maker, which is basically a service you can use right away, where you only have to put in your questions and answers, and the bot can consume it. So this would be the simplest form of a bot connected to a Q&A maker. You're up and running in half or 1 hour. And what we used for this little fellow, for our use case, is the custom vision service, in order to detect certain objects within a given image. And it comes like this. You have to, first of all, upload a set of images. In our demos, we usually take 30 images for training. So we take 30 images without a car, 30 with a car, upload them to our custom vision model. Then we tag those images, so we tag all the 30 which don't have a car with a different tag than the 30 ones with a car represented. And then we train the model, and after training it, basically you can use the REST endpoint in order to upload an image to the service. The service will predict, is the car here or is it not here, with a given probability. And of course, as I already said, not only doing it once, but iterating it to make it better and understand the environment better. And this is basically the area where the food truck comes in at our office. So this is the food truck we get served with food. And this is like the normal state. But we also have like these kind of settings where the parcel delivery service is parking in front of the truck, and we already we have here 98% detection that the car is here. So it doesn't matter if the service only sees a part of the car, but it detects like the real object. And even if the people are standing in front of the car getting their lunch, it still detects with 100% that the car is here. And it's not even a matter of an angle. So if the car is parking with a different angle, it doesn't matter for the service.
So what they are doing behind is that they analyze the training images, and you can think of it that they take the car and deconstruct it into tiny pixels of color, and those pixels are recognized in the new model. So they recognize, okay, I have this amount of this color, this amount of this color, and these shapes. So they don't look at the whole image. They create a lot of tiny images and fractions from this one layer, and then they see which, in the new image, what patterns are present there. And you use neural networks to do that. So they have a huge CPU power behind it in the cloud, and it's fast as hell. You can upload 30 images in, I don't know, depends on the internet connection basically. You upload them, retrain it takes 2 or 3 seconds, and then you have the images in the one. What's interesting in this picture is you see in the background you see a lot of green. So we started doing this last year around mid of May. So everything was green, the grass was green, the trees, and we realized going forward in the seasons, when November hit, in Austria November is gray and dark and it starts to snow, then the color scene is different of the whole scenery, and we saw a drop in the prediction. What we did was we took the car and made like 100 new training images with the car and without the car, and the predictions rise again because we retrained the model. So basically with the surroundings, when they are changing, you need to retrain the model. Otherwise, it's an intelligent service, but it's as intelligent as the day you trained it. It's not a self-learning system. You need to reiterate every time.
So for language understanding, coming back to the bots and agents thing, you can use LUIS, and LUIS is basically the language understanding intelligence service. They recently renamed it to just language understanding, so don't get used to the names. Just remember LUIS. And what it does basically, you have a given sentence like "Has the food truck arrived?", which could be an input from a user. And when you build up your LUIS model, you have to think about, let's say, intents. You have to think about entities. And what we did here, we have basically 2 entities, which is object and which is operation. And whenever a sentence is hitting the LUIS endpoint, it checks for those entities in order to understand the sentence. And if it detects the entities in there, it says, okay, this is intent A. So with this example, you have food truck is our object, and the operation is arrived, which we defined. And if those are matched in the sentence, LUIS checks, okay, the intent is check arrival state. You can basically set some actions whenever intent is check arrival state. And for building up a LUIS model, it's basically 4 steps. So create your intents and entities, as I said. But first of all, go to LUIS.ai, sign up, create entities and intents, then add utterances. These are the example questions and example sentences and phrases you want to train the LUIS model with. then train it, test it. If it's not perfect, just refine it, give it more userances, and train it again. And if you think the service is ready to go, just publish it, deploy it. Basically, you get a REST endpoint then, which is the same for all the cognitive services. Get a REST endpoint, talk to that REST endpoint. So, where does our launch bell actually ring? Our launch bell, as Tommy said, rings in Teams. So we have a bot which our users can ask, hey, has the launch bell arrived, or when will it arrive within Teams. But we also have the same in SharePoint. So we have like a SharePoint launch portal built up where the users can go to and ask bots and have the images there in order to check if the launch is already here for time. So let's go into the demo.
I will start by showing you some of the portals Stefan just had as an image here. For example, here we have one of our dev environments where we play with the thing. You see the same images there. Here you see a further iteration of the system. We already are adding the timestamp onto the image. So we go to the page and you see the latest timestamp. This was done in April, for example, and with the timestamp and the image name. And you see this. This was a special day because it was the long night of science in Austria, and they built up some pretty large roll-ups outside with a tractor there, and to attract more people. And we realized it sitting on the other side of the building because our predictions got messy. So I'm looking at the Azure storage table and seeing, okay, the car is not really detected what's going on there. And then I look at the images, okay, they're building something outside. Of course, the model isn't trained into this new environment. So this is where you always have to check. And what you can possibly do, for example, is that you go in there and you see here the truck pictures. This is just one sample library with 5,000 images, just from everyday usage. And I can go in there and see the different dates. Let's check for some new ones. This one, for example. And then you see the picture. You see the probability of the car here, the car not here. If we already try to detect also the DHL car, because this is also an interesting information. Or
for Amazon,
is the camera off because
delivers.
As you remember the pictures, this little red fellow from foam sits on the table, and sometimes the cleaning lady or a colleague from us moves it. So we realized, okay, the camera is off, and we already have an algorithm that checks at 8 in the morning, is the camera really in the right position? Otherwise, we get a notification to redo it. We have another bot or another Raspberry Pi with some servo motors can reiterate itself. So that if you go there deep, believe me. Another option would be like this demo page here, where we have the chatbot integrated into a SharePoint environment. You see here just a normal SharePoint intranet with some images from yesterday, for example, or for today. And then you have a bot here, and you can start interacting with the bot directly in the web interface. And the same bot here, like it's answering here, is the same one that we have here in Teams. So bots you can deploy to different channels. One here is the Teams channel. The other channel is here, the web channel, where it is just a web part. You can use it as an iframe, or you can use direct line, where you have your own web part that renders the bits, and you just talk to the Azure bot service via REST endpoints. And what we're going to do now is that we trained, before the session, we took 30 images with this car here. There's an Azure IoT service running there. We took 30 images without anything here present. So what I should be able to do is that I can say here, okay, like you saw here, I can start an interaction with the bot, and I can say check for the food truck work.
Yeah.
And then if everything works fine, what's happening now, our bot is calling to an Azure IoT hub. The Azure IoT hub calls back to this Raspberry Pi here. Raspberry Pi starts a shell script. The shell script takes an image, uploads the image to Azure, gives back the URL of the Azure Blob Storage to the Azure function, and the Azure function calls the custom vision API and checks if we have the retrained model from an hour ago and tries to detect the car in the image here. Let's see. So 0.0001%, the actual image, the car is not here. And if I'm going now to see if I have the right angle, somewhere like this.
Should be at least more. Yeah.
Stefan, this is right, sir?
Yeah. As Tommy said, it's the trained model from like 11.10, so don't blame us if it's not like 100%.
It's always depending. You see it in the image here, there's a lot of beige and light yellow color in the background. Our car is also yellow. We've done this session now a few times, and it's always depending on what's in the background, because we only have 30 images, but you should see a different result here. There is a timer waiting for 25 seconds, so I'm not worried. It's just to make sure that everything works. And then you see it's 0.01, so it's a high probability. There's a difference. And what you need to do is that you need to take a lot of sample images. We only take 30 exact same images with the car and 30 exact same images without the car, just in terms of preparation here, and you already have difference. If you could start like training the image with a car like this or different ways, let's try it actually. We'll put the car in that sense. You would get different results. So you need to train the model, and then don't expect it something like, okay, it's 100%, it's never 100%. So you had to do something like a threshold. It's like, okay, everything above, I say it's true, and then the bell rings. And the more is there in the surroundings, the more different variables are in the picture, the threshold goes down. And we actually, in our working environment, we don't only look at the probability of the car detected, we also look at the probability of the car not detected. We check for anomalies, is there something off, so you see everything.
But just one thing, if the food truck has not arrived yet at our office, Tommy, please ask, when will the food truck arrive actually? Because this is then the next step for getting machine learning into all those data we actually store, feeding machine learning services, and the machine learning services then predict when the food truck will arrive at today or Monday or whatever, like the exact time with traffic jam. We've not implemented this yet, so you can basically just ask for a choke, which is at least one possibility to get your users using your service. So this is also one important thing. Whenever you build a bot, make sure you implement like small talk features in it, because every user will ask, hey, how you doing? Who are you? What's your name?
Create you. What are you doing in the evening? You get the nastiest thing immediately.
Yeah. So always when building bots, implements like at least a tiny small talk service in order to get like the conversation fluently done, and like in this case, if it's like a joke, it doesn't matter.
Okay, thank you so far. Question and answers now.
Everyone asking a question can get a Mozartkugel from Austria.
I asked a lot of questions.
So for example, why do you store images on SharePoint instead of Azure Storage? It would be probably much cheaper.
We store them in Azure and in SharePoint, but in SharePoint I can do something like, I can go there as a normal user, and I can say, okay, this image is detected wrong, and then I can add a webhook there and retrain the model. You lost it. That's your bad. But in SharePoint I have a user interface where I can go in and say, okay, click renew, retrain, and then I can build something like a self-service portal where you can say this image is wrong, it's actually this, and the API then retrains it behind it. That's the reason.
Thanks.
Okay, but then the future with the direction of those solutions.
Yeah.
Okay, thank you. Is Azure some predictive on those time arrival of
Yeah.
other things?
Yeah, because
What techniques do you plan to use? Or do you think about it? Or machine learning? Or
machine learning, but we need more variables.
Yeah.
We're thinking of the current weather situation, because the weather has influence on the traffic information from the city, because we have a
This
database.
will be quite complicated.
Yeah.
Otherwise it's not a challenge.
Yeah.
So you build a lot of variables, and then you build a support vector machine that learns and predicts the things. It's a totally different thing Monday to Friday, for example. Traffic on Friday is different than on Monday. On Friday it's here even 4 to 15 minutes earlier, and we're talking about minutes off. Between 4 to 7 minutes off the days. And this is the prediction, and then you have this special bridge days where the Thursday is a free day and the Friday is special because no one is in the office and there's less traffic. We have a lot of variables to account there. But we're thinking of getting traffic information, weather information, and we also talk with the guys from the company because they use it as like a little advertising the solution about getting information who's the driver, because the driver is also a variable. Yeah, you get deep.
Okay, as I understood, the next point will be completely destroy this system because you will integrate with the vendor, those food truck.
Maybe.
Maybe.
Yeah.
Two questions.
Two questions. You want two? Yeah. Of course, my friend.
But the first question is, what is your name? So
Your surname, right? Basically, how many times did you got some false alarms about the sandwiches? About the car, food car?
Not so often. There were sometimes, and the most of the times it's like you saw the different cars arriving, the yellow one, and there's another vendor also bringing food. It has a green painting on the side. Most of the time it's like when both cars are present, then the system is like, okay, for 80% I'm sure it's here, but for 70% I'm sure it's not here. Because it's not mutually exclusive, it's just classification, it's just image tagging. For us it's like, it's either this or that. So if you start adding up the probability and you end up like something 142%, what the fuck is going on here? No, it's the brain bug. It's not mutually exclusive, but not so often, to be honest.
Okay, and when will you start selling it? Because every company has the same problem, right?
Yeah. Currently not planned to sell it. It's on GitHub, you can use it for free. So everything, I don't know if it's the latest version, but we're just publishing for free. We don't want to make money of this, it's to be honest, we started it and some other guys in the company also work for it. It's for us the best way to learn the whole Azure communication, authorization, security stuff with a fun project.
Okay.
That's the good thing.
Additional question about those.
Additional other question.
No.
This is a hard
It's
one or
not
what?
for
Okay.
not for candies, rather for curiosity.
Yeah.
Okay. When we talking about learning based on those projects, how many time you use for those pet projects as is? You do try to estimate. Of course, it's learning for future services and so on, but I'm curious.
Yeah, the point is, as we already mentioned, you start with one piece.
Yes.
You say, okay, this is done within like 2 days, and then you have another idea. Okay, this would be cool, and this would be cool, that would be cool. So it's like you can't you can't make a calculation how much you will time it will take before.
But first result you get in those 2 days.
Yeah. It was the first technical breakthrough was 1 weekend for me. From setting up the Raspberry Pi, everything to Azure, first Azure function, customization API, and I back then just used the connector for Teams, was done in one weekend. And not weekend, not hardcore death weekend, more like relaxing and 12 days together, like 6 or 8 hours. But then, if you're going this direction, then you have ideas and ideas and ideas. So there was another question? Yeah.
Very simple questions. Are you planning to integrate your solutions with the Google Alexa? You told about Google Alexa, but not Amazon Alexa, sorry. But with Google Assistant, we know at last Google Assistant this year will be in Poland.
Yeah.
As applications and solutions, and maybe other ecosystem like Siri.
We plan to do two things here. At first, we can, with our simple table storage, just as the information the truck is there or not there, you can connect easily to other systems like Alexa or Google. But going one step further, wouldn't it be cool to do the same thing on the Google framework and on the Amazon framework and compare the results? So using the same images, upload it to a cognitive services model in AWS or to Google and see the difference. That's the next thing. So we can go to Microsoft.
The next big thing.
The next big thing. Yeah.
You get 3 systems to predict something.
Yeah, and I have a bet with a guy from AWS. He says we are faster, and then let's see. So maybe next year somewhere. Yeah.
This learning.
Last question.
Yeah. Okay.
Not the last, we can talk
this
outside as
learning
well.
goods on Azure. They are paid or they are for free for the moment?
We are using a consumption-based bot,
Yeah.
and the whole system costs me. The bot only is like €2 a month.
€2.
Yeah. So if you go for the fixed cost, it would be €30 the whole system. Consumption-based, I'm normally using for everything with the storage €6 or €7 a month. Always go check for the consumption. It's way cheaper than the fixed. Okay. Thank you guys. I leave the rest just here for the.
If you have any further questions, we're still around the whole
Yeah.
day, so just ask.
Enjoy your day. Thank you.
Thank you.